Ready? So good morning all of you. The summary of the last lecture, what we have discussed, free electron contribution to the specific heat, and I have given a task to find a total number, density of states already we find, okay, and a total number, total energy, average energy and a Fermi energy for 1D and 2D. Have you completed? Everyone? Now, right, wait a minute. So till now what we have done, we have taken non-relativistic. 1 minute, listen, see the board carefully, very important Babu, very important. Non-relativistic. 50% of the questions based on this. Listen. Non-relativistic means of course ideal. That's why energy equal to, we got h cross square k square by 2m. That means your energy is a proportional to k square. For this you have done something. What is that? Density of states. Next number. Next energy. Next Fermi energy. Next average. This is what you have done. Okay. So let me take first shall I write 3-dimension table? I think this is better, 3-dimension. 3-dimension and next 2-dimension and next 1-dimension. Okay. So now first I request you write the density of states. The density of states for 3-dimension, V by 4 pi square 2m by h cross square whole power 3 by 2 e power 1 by 2. Am I right? If you take the spin degeneracy, here it is 2. Otherwise, like you can write like this. Good. And next for 3-dimension, I would like to write the Fermi energy. I don't want to write that number and total energy. I want Fermi energy. Fermi energy, come on. H cross square by 2m 3 pi square n whole power. Oh, sorry. 2 by? Good. And sometimes, be careful. We want to find kf. K? Be careful. Kf, while you are finding, what will happen? EF equal to what? PF square by 2m. PF is what? H cross square, KF square. So KF square is equal to something. Then KF equal to whole power 1 by 2. That's why 2 gets cancelled and you will be having a 3 pi square n whole power 1 by 3. Good, wait a minute. And after that, I want average energy. The average energy, I think here you got 3 by 5 EF. Like that, I request you fill this 2D and 1D. Only density of states, Fermi energy and average energy. If you have already solved, please fill this 2D and 3D. Same G of E, density of states, as well as Fermi energy and average energy. Density of states, Fermi energy and average energy. This is a strongly degenerate. What we are discussing is a strongly degenerate. Strongly degenerate case, the Fermi energy is independent of temperature. It depends only on the density. See the notebook and write. How we will remember. But you should remember. Otherwise you have to derive in the exam. If they are asking Fermi energy in 2 dimension, what you will do? If you remember it, it takes less time. Otherwise you have to write the density of states. From that you have to find capital N. From that you have to find EF. But don't forget to multiply with 2s plus 1. Here without degeneracy you are writing. Or else you can write with degeneracy, 2s plus 1. Right. Now could you please tell me in the 2 dimension what is the density of states? 2 dimension means area. Area by 4 pi 2m by h cross square whole power. No whole power. 2d. So e power 0. Next EF h cross square by 2m. Very few people are saying whole power nothing into 2 n pi. Have you done? But very few people are saying the answer. Open your notebooks. Everybody completed? Those who have not completed, please go out. Next, average energy. How much you got average energy? 1 by 2 EF. Next, 1 dimension. 1 dimension density of states, what you have written, tell me. L by 4 pi 2m by h cross square whole power 1 by 2 e raised to minus 1 by 2. Sit down. Fermi energy, what you have written next? First say this, h cross square by 2m n pi whole square, n pi whole square, is it? I think there should be 2 better, 2 n pi, okay, 3 dimension, 2 dimension, 1 dimension, okay, right. Average energy, next. 1 by 3 EF, stop. That's good. Now listen carefully. In 3 dimension, density of states is a proportional to. In 2 dimension, density of states proportional to. In 1 dimension, density of states proportional to. Right. Now everyone, please observe how I am writing this. E power 1 by 2. Okay. What is the dimension? Can I write like this? E power 3 for dimension by, what is this E proportional to k square? That is 2 minus 1. Check. Shall I write? 3 by 2 minus 1, how much? Next. Now I am writing this 0 as e raised to 2 by 2 minus 1. Shall I write? Next. Minus 1 by 2 I am writing e power 1 by 2 minus 1. Shall I write? Now observe carefully. This numerator, dimension. This denominator, 2 k square. So the numerator is a dimension. Is that clear? That's why if I take a d dimension and my energy is a proportional to k square, more general. D dimension, energy proportional to k power s. Energy proportional to? I am taking more general. This is a k power s and d is the dimension. Could you please tell me g of e, density of states proportional to e power? Are you ready? Dimension by power minus 1. Dimension. So the density of states more general in the dimension d and the energy proportional to k power s. G of e is a proportional to e power d by s minus 1. Next, Fermi energy. Ready? Now how I am writing this? This 2 is a k square? 3 dimension. So yes or no? Here 2n pi whole power, shall I write it as a 2 by 2? 2 again k square, 2 dimension. Ready? Next again. This 2 can be written as a 2 by 1. This 2 again k square. This 1 dimension. Now tell me, EF is a proportional to n power 2, the power of k, 1 dimension. Power of k? S by? Okay. Next, come to this. Ready? So 3 dimension. What is the answer? 3 by? I am writing this. 3 by 3 plus 2. Shall I? Okay. Next, this one I am writing 2 by 2 plus 2. Shall I? Next, this one I am writing 1 by 1 plus 2. Shall I? Now see, this 3 for dimension, 2 2, 1 1, 2 2 2. Now tell me, the average energy more general, 1 for dimension, 1 for dimension, 2 yes into EF. They are not active. This is the more general forms for any dimension and any power. You can take relativistic also. The relativistic, once you take what is energy? Pc. What is P? H cross K. Then K power how much? And in all these formulae, S is replaced with what? 1. You need not to do it again and again. So this is the more general relations for dimension D and any kind of energy. Clear? Very important. You must remember this. Now I will ask you within 2 minutes, please practice. Density of states proportional to E power D by S minus 1. Fermi energy proportional to E power S by D, N power S by D. And average energy is a D by D plus S into EF. Please practice on the rough paper. Don't forget, density of states proportional to E power D by S minus 1, and Fermi energy is proportional to N power S by D, and then average energy is D by D plus S into EF. Everybody come and say, density of states G of E proportional to E power D by S minus 1. Fermi energy EF proportional to N power S by D. Average energy equal to D by D plus S into Stop. This is 2 times given in CSIR. Simply question is the same, specific heat is proportional to what? Something he will describe, finally he will ask at specific heat is proportional to. What he will describe? Energy, energy is equal to H cross Ck or something, whatever the system he will define, and finally he will ask what is the specific heat proportional. Of course, specific heat is proportional to what? T power. Are you ready? Okay, if you want to find specific heat, what you have to find? U lattice, total energy of the lattice, means average energy or anything you can take, an average energy or total energy, okay, whatever it is. So finally I want to find the total energy, say yes or no. Okay, so I am writing U, but it is a total energy. So everybody know total energy is integral. Okay, so just I am writing E, F of E, G of E, D. F of E is a Fermi distribution, that is a 1. Shall I remove it? Okay, after that come on, G of E, D. D of E, G of E, D of E enter. 0 to E. 1 minute. I am not bothering about the total value, just proportionality. Okay, so this is a proportional to integral. Here what you have? E. Your density of states more general contain E power d by s minus 1 and integration with respect to what? Are you observing? So this is a proportional to integral. Could you please tell me E power d by s d? Say yes or no. Now I am going to integrate that. Then sorry, not total, proportional, e raised to integral d by s plus 1 by, I don't bother about this constant, that's it. Finally I got u is a proportional to e power d by s plus 1, but e is a kt, kbt, not kbtf, kbt. If it is a Fermi energy, kbt, kbtf. If it is simply energy, kbt. That's why kb gone, constant. Come on, say t power. Understand? Now everybody know specific heat Cv equal to dou u by dou t. So t power d by s plus 1 differentiation is how much? D by s plus 1 t power. That's it. Proportional to t power. In the question he will give 3 dimension or 2 dimension something, and he will give energy relation something, and take that k power and take the dimension, and the specific heat is a proportional to t power. Come on, write down. If you have written the table form, please add that Cv is a proportional to t power d by s. Now get ready with the problems. I am discussing all the questions till now, whatever they have given in this Fermi, free electron theory, I am giving, please try to solve. Don't forget the original one. Original one means this one, general. After that, whatever the condition has given, you simply substitute D and S. First problem. Ready? Yeah? Or you want to practice? Ready? Be serious, 5 marks each question, don't neglect. This is a 5 marks question, write down. The excitation of first problem. The excitation, leave the space and start in the fresh space. The excitation of 3D solid, underline 3D, 3D solid are bosonic in nature, with their frequency and wave number are related as omega proportional to k square. Underline that k square. Could you please tell me what is your S value? What is your D value? Now what is the answer? Full stop. Are related as omega is proportional to k square. Full stop. If the chemical potential is 0, the behavior of specific heat of the system. Maybe you are getting a doubt. Sir explained fermionic system. This is the bosonic system. Remember, fermionic behavior, bosonic behavior same. Fermi temperature is proportional to n power 2 by 3. Bose temperature is also proportional to n power 2 by 3. Constants values may be different. Proportionality is the same. I repeat, Bose temperature, Fermi temperature, everything is proportional to n power 2 by 3. That won't change. Understand? Write down. The behavior of specific heat of the system at low temperature is A, T power 1 by 2, B, T, C, T power 3 by 2, D, T power 3. If you have any confusion, in StatMech we will start the Bose system, Bose gas. There we will derive Bose temperature. Then you will understand both are same. Both are same proportional. T power same. Next problem. Answer. T power. Next one. Consider, this is the just question. Consider capital N number of identical electrons. Consider capital N number of identical electrons distributed in a cubical box. Underline cube. What is the dimension? In a cubical box. Full stop. The energy of the system E equal to C k power 4. Underline k power 4. Energy of the system is E equal to C k power 4. Find the ratio of average energy to Fermi energy. Find the ratio of average energy to Fermi energy. What is the formula of average energy? D by D plus S. What is the dimension given? 3. What is S? Answer. In the sepa 3 by next, third question. So I think you know E bar equal to D by D plus S. Okay, that's why this is 3 by 7, and here this CV proportional to T power D by D by S. Next problem. If the number density of a free electron gas in 3D, underline 3D, in 3D is increased 8 times, underline that free electron is increased 8 times. How many times increase? 8 times. What it is increased? Number density increased by how many times? 8 times, comma, its Fermi temperature will be, so he is asking Fermi temperature means first you have to take the Fermi energy. Could you please tell me for free electron and the dimension is 3. Fermi energy is proportional to n power s by, that means n power, s is what? Free electron 2, d is what? Very few people are saying. You don't want to get 5 marks, I think. If you are not saying, you won't remember. So EF is nothing but what? KB TF. So this is the TF proportional to how much? N power. Now this N is increased by how many times? Tell me the answer. 4. Increased or decreased? Just right. Options given. This is December 2011. Increased by 4 factor. Increased by a factor of 4. Increased by a factor of 8. Decreased by a factor of 4. Decreased by a factor of 8. TF prime is proportional to 8 power 2 by 3, which is equal to 2 cube power 2 by 3. 3 gets cancelled. Finally, the new Fermi temperature become how many times? 4 times. Next, fourth one. Consider a system, a simple question. Consider a system of non-interacting particles in d dimension, and obeying dispersion relation, E equal to a k power s, then density of states proportional to, come on, do it, very simple, I need not to say anything. Density of states is proportional to E power d by next one. This is December 2012 and this is June 2012. Next one December 2012. The radius of Fermi sphere, the radius of Fermi sphere, the radius of Fermi sphere of free electrons, underline free electrons, the radius of Fermi sphere, sphere means 3 dimension, Fermi sphere of free electrons in a monovalent metal, in a monovalent metal with an FCC structure, underline FCC, the radius of Fermi sphere of free electrons in monovalent metal with an FCC structure, underline FCC, the number of atoms per unit cell of FCC, how much? FCC structure in which the volume of the unit cell, in which the volume of the unit cell, in which the volume of the unit cell is A cube, is A cube, is A cube, comma, is option. And what he is asking is radius of Fermi sphere. He is asking radius of Fermi sphere, options write down. Ready. Now what he is asking? Radius of Fermi sphere. You stand up, Amma. You only. Huh? What is the Fermi energy in 3 dimension? Okay. What is the relation between Fermi energy, EF, and momentum? If Fermi energy is given, how we will find the momentum PF? How we will find KF? Sit down. Anybody remember on that day while I am explaining the density of states, I have drawn that sphere and the radius we have taken K. Listen. So here this is the sphere, okay, and here they is asking Fermi sphere. This is the Fermi sphere. Fermi sphere means simply the boundaries of a Fermi energy level. Is that clear? Then what could be the radius of the sphere? Kf. Now everybody know what is the Fermi energy in 3 dimension. Come on, say. If you are keep on saying, then only you will remember, otherwise impossible. Whole power 2 by 3. Now I want Kf, that's why h cross square k square by 2m, of course Kf square. So h cross square by 2m, h cross square by 2m cancel, and Kf equal to 3 pi square n whole power, because the 2 gets. Now could you please tell me, this is the 3 pi square, what is this? N by V whole power 1 by 3. Now which structure is given? The number of atoms in the unit cell n equal to, that's it, come on. We are doing for that unit cell. Check what is the answer. A na, B na, C na? A. Ready. Next one. This is June 2013. If the energy dispersion of a 2D, if the energy dispersion of a 2D, underline 2D, 2D electron system, 2D electron system is E equal to U H cross K, underline that, E equal to U H cross K, where U is the velocity, where U is the velocity. Then the density of states, proportional to E power. Now what is the density of states formula? G of E is proportional to E power D. Yes, do it. Yeah. Next, June 2014. Nice question. Good. Write down. The pressure of a non-relativistic free, underline. The pressure of a non-relativistic free, underline non-relativistic free. What is the meaning of non-relativistic free? Energy is proportional to K square. A non-relativistic free Fermi gas in 3 dimension, in 3D depends at 0 Kelvin and strongly degenerate, depends at T equal to 0 Kelvin, comma, on the density of fermions, n, small n, as A. He is asking pressure. See, till now we have done energy, density of state, something, but here is asking pressure. Don't get tension. So options, write the options. N power 5 by 3, small n power 1 by 3, C. Small n power 2 by 3 and small n power 4 by 3. Option D, small n power 4 by 3. Wait. Ready? See, whenever you are doing the problem, always remember, first focus on what he is asking. What he is asking? Pressure. One thing is very clear, this is the 3-dimension system, non-relativistic. We know all the result. Fermi energy, you remember, I think. Fermi energy EF is equal to H cross square by 2m, 3 pi square small n, whole power 2 by 3. Good. Pressure he is asking. So thermodynamics you have to go. Anybody knows how to find the pressure? Anybody knows what is the formula for pressure? P equal to? Energy by volume in terms of thermodynamics laws you have to say. You should not say by using dimensions. Thermodynamics laws will be there now. First law, second law, third law. With that framework you have to say. pressure equal to minus dou E or dou U, U for energy, dou U by dou V. Okay, pressure equal to minus dou U by dou V. Maybe long back you studied, written. So stop, don't write. Pressure P equal to minus dou U by dou V. Remember, U is the total energy. You can write it E also, no problem, no issue. Dou U by dou V or something like that also you can write it. How to get total energy? Sir, we know average energy, sir. How much? Average energy equal to 3 by 5 EF, sir. Oh, fine. But I want a total. No problem, sir. Multiply with N. That is the average energy for one system. Total energy into N. So that's why I hope you got it. U equal to N into 3 by 5 EF. Careful, careful. If you have not taken this N, you will get one answer. That answer is also there. If you miss this, if you have taken this, you will get the correct answer, otherwise wrong answer. See. And everybody know what is EF, that's why I am writing N, come on say 3 by 5. What is this? H cross square by 2m. Sorry, small n is nothing but capital N by V. Sir, why you have written? Array, I want differentiation with respect to V. Is that clear? Okay. Now, forget everything. He is asking only proportionality. That's why constants, everything is removing. Only keeping this capital N, because that is a number, into some constant. Okay. Otherwise, some constant N. Here it is N power 2 by 3 into V power minus 2 by 3. I think this is a C. N power 5 by 3 into V power minus 2 by 3. Clear? Now, as for that formula, so pressure P equal to minus dou U by dou V. Ready? Differentiate with respect to V. That's why minus will come. Minus minus gets gone. C constant N power 5 by 3, 2 by 3, V power minus. Now, this pressure is a proportional to constant to gone. This can be written as N by V whole power I told you this free electron theory is very important. See how many questions they are asking every year. Every year is there. Almost 95% all years. Only 1 or 2 exams miss. Ready, next one. I will read, I think it's too lengthy question, theoretical question, not mathematical. That's why you can listen and say the answer. This is the December 2014. Consider two crystalline solids, one of which has simple cubic structure and the other has tetragonal structure. The effective spring constant between the atoms, one is simple cubic, another is a tetragonal. The effective spring constant between atoms in a direction is half the effective spring constant between the atoms in another direction. In one direction spring constant is half of the other direction, means he is talking about what oscillation frequencies, and one direction it is double, another direction it is some half, something like that he is saying. Wait, at low temperature the behavior of the lattice contributions, lattice, I repeat, lattice contribution is asking, lattice vibration contribution, lattice contribution to the specific heat, okay, only lattice contribution is a proportional to what? A, T square for tetragonal, T cube for simple cubic. T for tetragonal and proportional, T cube for simple cubic. C, T for both, D, T cube for both. In your entire derivation of lattice vibrations, do you have any concept of tetragonal simple cubic structures? It is independent of the structure. So the lattice contribution is a proportional to T cube. Write that. Somewhere, where you will write? In the lattice contributions, go to the lattice contribution concept. You have finally derived something proportional to T cube, you have written somewhere, final derivation. Lattice contribution, finally you shown that CV is proportional to T cube. Finally you have shown that CV is proportional to T cube. That Debye model. Under that write down. Lattice vibration contribution to the specific heat is independent of lattice vibration contribution to the specific heat is independent of crystal structure, remaining all the things are constants. Check derivation, where is the derivation? Final derivation is there, we have done derivation. Till now you didn't get the derivation, T cube, there I told you to write. Next one. No need to write. Because the repetition earlier given, again June 2015 given. The low, listen and say the answer. The low energy spectrum, the low energy electron excitation, in a 2D dimension, 2D sheet of graphene is given by, under dispersion relation, is given by H cross V K. K power 1. Dimension 2 K power 1. Then density of states proportional to E power D by S minus 1. D 2. Yes sir. Answer. Next problem, write down. This is December 2015. Okay, before writing that, I will read the question. This is June 2016. Read the question and say the answer. Ready? Consider, see, they are not asking any complicated things. Complicated also there, but maximum they are giving easy questions, but complicated questions also there. Consider electrons in graphene, which is in a planar nano atomic layer of carbon atoms. If the dispersion relation E equal to Ck, dispersion relation Ck, K power 1. S equal to 1. The Fermi energy, that graphene is a planar, means what is the dimension? 2. Now Fermi energy depends on the number density n, as Ef is proportional to n power S by D. N power S by D. Here S is 1. D is 2. N power 1 by 2. Wait. Still, if anyone is there like that, just I am checking. Ready? December 2017. The dispersion relation of a gas of a spin half fermions in 2 dimension. Dimension 2 is E equal to H cross nu into K. What is K power? 1. Dimension 2. K power 1. Full stop. E is the energy, V is the velocity, something given. If the Fermi energy is EF, then, ready? Number of particles per unit area. Number of particles per unit area. Don't get tension. Number of particles per unit area is proportional to EF power. So don't get tension. First say EF. EF is proportional to n power S by D. Your S, 1. Your D, 2. So n power 1 by 2. So EF is proportional to n power 1 by 2. N is proportional to EF square. EF square. Ante. Now come back. Right down. A thin metal film number. A thin metal film of dimension 2 mm by 2 mm. 2 mm by 2 mm contains 4 into 10 to the power of 12 electrons. Is it a 2 dimension or 3 dimension? 2 dimension. Good. Electrons, full stop. The magnitude of Fermi wave vector. The magnitude of Fermi wave vector of the system. For free electron approximation. The magnitude of Fermi wave vector. The magnitude of Fermi wave vector of the system in the free electron approximation. Wait, don't get attention. All are easy questions, but don't give up in the exam. Please answer. Right, wait a minute. Now you understand one thing. This is the 2D system. Say yes or no? 2D system. Okay. What he is asking? Magnitude of a Fermi wave vector. So he is asking what? Kf. If you want to find Kf, first what you have to find? EF. Ready? This is which system? Two dimension. Now what is the two dimensional? Fermi energy. Fermi energy two dimension. Two dimension. No. Full value we want. Why? He has given the number, numericals. That's why you have to know the complete one. This is what I said. If you forget that, there is no other choice, you have to derive. The student who remember, he will get the, within less time he will get that answer. Otherwise, you won't do. What you will do? Who will do the density of states and integration? Leave it. This is the very lazy people will do like this. So I don't know why you doing to practice. I told you yesterday, please practice and come to the class. Two dimensional. H cross square by 2m, 2 pi n, or 2n pi. See, whether to learn or not, it's up to you. My job is done. Still, nobody learned. What is the, everybody learned? Shall I ask now? H cross square by 2m, this is a 2 pi n. Okay, so this is h cross square by 2m, 2 pi n. EF is nothing but h cross square k square by, now this is h cross square, 2m gets cancelled. Finally, k equal to 2 pi n whole power 1 by 2. 2 pi, this is nothing but n by a whole power 1 by 2. 2 pi is okay. N is given 4 into 10 to the power of 12 and area, this is millimeter. So please convert into meters. Come on. Millimeter, how many meters? 10 to the power of minus 3. 10 to the power of minus 3 into 10 to the power of minus 3. 10 to the power of minus 9? Minus? Inka 9 10 to the power of plus 9 alla. See how easy questions they are asking. But you should remember all the things. Please practice. Oh, answer given in terms of centimeter. No. Second option, sir. Carefully see. 2 root pi, root 2 pi. Huh? No. Root 2 pi. Okay. Correct. Here, if you remember the formula, it's simply converting millimeter to centimeter, something like that, nothing else. If you are able to convert, you will get the answer. Next one. Don't forget the density of states or density of vibrations. Don't forget. Only the difference is density of states will take in terms of energy. Density of vibrations will take in terms of omega. I hope you remember. So how we will replace a k? So velocity is equal to omega by k. K is equal to omega by velocity. Write down. This is June 2016. And that is 10 to the power of 12. 4 gets cancelled. 10 to the power of 12 by 1 millimeter into millimeter. 10 to the power of minus 2 5. Oh, 10 to the power of 14. Oh, 10 to the power of 14 whole power 1 by 2. Finally, it will be 10 to the power of 7. Right. Suppose, nice question. Suppose the frequency of phonons, whenever they mention phonons, then you have to go to omega terms. Suppose the frequency of phonons in a 1D chain lattice, in a 1D, so which dimension? One dimension. In a 1D chain of atoms, suppose the frequency of phonons in 1D chain atoms is a proportional to wave vector k, means omega proportional to k, is a proportional to the wave vector k, full stop. If n is the number density of atoms, if n is the number density of the atoms and c is the speed of a phonon, and c is the speed of phonon, then find Debye frequency. Find Debye frequency. Take the options. Take the options. Find the Debye frequency. No need to get tension. Now ready. Stop. I will explain. Okay, so this is a phonon spectrum. That's why we have to go to which model? Debye model. So in Debye model, for every problem we need to find what? Density of states. But here density of states, no. Density of lattice points or density of vibrations, something like that. Ready? You remember how we have find? No, I think no. Very less response. One dimension. In one dimension, how we will get the number of lattice point? Length by length. Okay. So length is what here? K by pi by. But some books, they will take it as 2 pi by L. If you take pi by L, you have to write 1 by 2 separately. If you take the Brillouin zone length, I said already, I don't know how many of. So if you take the Brillouin zone length, no need to write 1 by 2, 1 by 4 separately, simply whole square or something. Maybe, otherwise again you will get confusion. But if you are seeing SSP books, there will be a 2. 1 by 2. This is L by 2 pi into same whatever we have done the derivation, the same thing. But we should replace this one. Wait a minute. Now dn equal to, could you please tell me, L by 2 pi into, now he already given omega is proportional to k, means omega equal to velocity. Velocity is given as a c. Yes or no? Now this is anything you can take. D omega or k equal to anything. K equal to omega by c. dk equal to d omega by c. Now dn equal to L by 2 pi into dk d omega by c. Finally, this dn can be written as, I hope if you remember what we have written there, g of e. But this is not g of e. What is this? G of omega. Is it okay? So equal to L by 2 pi c into, okay. Now what do you want? Omega. Now ready? Okay, just take this dn, integral dn, or anything you can take, this one also. L by 2 pi c integral d omega. Wait. I am taking this is simply n equal to L by 2 pi c. This is what? Omega. I told you the maximum frequency is the Debye frequency. That's why this is what? From where to where? If you remember that derivation, we have taken maximum 0 to omega d. What he is asking? Omega d. Omega d equal to 2 pi c n by L. N by L is nothing but what? No need to write this, either g omega or simply keep it as a dn only, because directly we are integrating, no issue. So don't feel that SSP questions are easy, difficult or something like that. Easy only, but you have to remember all the formulae, concept, everything. Oh, I thought that today problems will be complete, and one more is there now, at T not equal to 0 Kelvin, Fermi energy. That will be complete. After that some time will be there. That's why I thought to bring. It's going slow. Come on. It's okay, no problem. Tomorrow please bring only SM notebook. Micro canonical ensemble will be complete tomorrow. After lattice vibrations, we will start band theory of solids. Once band theory of solids over, only you left with superconductivity and Hall effect. I am not explaining for total 3 questions. I am explaining only for 2 questions. Total 3 questions not possible within 20 days, 15 days not possible. Ready? Next problem. This is December 2018. Right down. The dispersion relation of optical phonons in a cubic crystal, cubic underline, in a cubic crystal, omega of k equal to omega naught square minus ak square. The dispersion relation of optical phonons in a cubic crystal is given by omega of k equal to omega naught square minus ak square, where omega naught and a are constants. No need to write, full stop. The contribution to the density of states, due to these phonons, he is asking density of states due to these phonons is a proportional to, take the options. Don't get tension. No need to get tension. Aram se. What he is asking? Density of states. Wait. Is it a 3 dimension or 2 dimension or 1 dimension? Right. Stop everyone. This side there is no voice, anything. No one is. Everybody is sleeping. You don't want to clear the exam. 3 dimension. Number of lattice points in 3 dimension. 3 dimension. I am asking number while you are deriving. Here earlier I explained for 1D. This is 1D. Like that we have written first step 2D, 3D. I think yesterday, I think in the beginning of the first class, I think yesterday starting we have done density of states of 1D, 2D, 3D. After that only we discussed.
1 by L, 5 by L by L.
I don't want simplified answer. I want just what is the volume by what is the volume? Volume by volume.
4 by 1 by 4 by third 5 K cube 5 by L
Whole? Whole cube. Whole cube. Whole cube. Sit down. Now n equal to 4/3 pi k cube by pi by L whole cube. Because it's not possible to remember each and everything. That's why I told you how we got this. Into how much? 1 by 8. Cool. He's asking proportional. 1 by 8 aitundo, 1 by 2 aitundo. Okay. So me Anandam. So this is V by, I think you will get a 6 pi square k cube. At least either this or this you must remember. Otherwise we can't do anything. Now finally, ready. So dn equal to V by 6 pi square 3k square dk. So you have to substitute this in terms of omega. Are you ready? Okay boss. Now omega equal to omega naught square minus ak square. What do you want? K. So k square equal to omega naught square minus omega by, I don't want. Why? Proportional. Right. So k equal to this one. Now once you got this k, of course k square you will get. Come on, say dk 1 over 2 under root omega naught square minus omega into okay into d omega. I don't want minus. Okay. Right. If you want, right. Now take everything and substitute here. So dn, I want only proportional. So this is no need to consider. K square omega naught square minus omega square into dk 1 by under root. Now it's a no, dimensions not sorted. So omega naught, okay, minus ak square. So omega naught minus omega. Now that implies, come on, say dn is a proportional to k square omega naught minus omega into by under root omega naught minus omega. This is implies omega naught minus omega whole power. So what is the option? Amma, please correct this. Not omega naught square, omega naught. Now I am explaining all CSIR questions based on Fermi energy, free electron theory. You please solve from gate questions. If you have interest, please solve. Only free electron theory of metals. Debye model, specific heat, all these things, whatever we have discussed. Lattice vibrations. Next problem. Right. It's a nice question. This is December 2017. A metallic nanowire, a metallic nanowire of length L is approximated as a 1D lattice. Tell me what is N for 1D lattice? N, capital N. K by pi by L, but into 1 by 2. A metallic nanowire of length L is approximated as a 1D lattice of capital N atoms with lattice spacing A. Full stop. The dispersion relation is E of k equal to E naught minus 2t cos ka. E naught minus 2t cos ka. Be serious, Babu. And E naught and T are constants. Full stop. The density of states depends on E. The density of states depends on E as write the options. I will wait for 2 minutes because this is the last question. Let us see how many of you will do. So it's a one dimension. First you have to write N. How you find the density of states derived, you remember. Once you got N, what you have to do? Dn. Dn is in terms of dk, and here you have to substitute dk. For substituting dk, he has given something. Try. Just I will wait for few 1 minute, 1 or 2 minutes. You have to get a dk from that. So first find a de, then you will get a dk. E naught is constant, T is constant. Tomorrow is the last Sunday, you hear it? Huh? One more Sunday is there. Huh? Okay, next Sunday bring money, we will celebrate party. Calicut also, you also please bring money. We'll celebrate online. Just do one thing. So bring your own whatever sweet you like, you please buy. Whatever the cool drink you like, you please purchase. Please bring all those things and gather here and celebrate. Over, party over. Option B. D. Good. Right, very nice. So this is 1D number, 1D lattice. 1D lattice n equal to, this is the k by pi by L into 1 by 2. That's why L by 2 pi into k. Never be afraid of the question by seeing that. Whatever you know applied, your sir already explained all the derivations. Any problem framed, it must be in the derivations only. dn equal to L by 2 pi into dk. So we want to get a dk. For that they have given a dispersion relation E equal to E naught minus 2t cos ka. Okay, so from this I can find dE, this is a constant, minus 2t cos differentiation sin ka into a. That's why minus 2ta sin ka into minus minus plus into dk. Now this dk equal to dE by 2ta sin ka. That's it. So now you can substitute this. dn equal to L by 2 pi into dk. This is a dE by 2ta sin ka. I think you have to replace this sin ka with the cos ka, I think. So from here cos ka equal to E minus E naught by 2t. That's why sin ka equal to under root 1 minus cos square ka. That implies 1 minus E minus E naught whole square by 2t whole square. Just substitute. These are all the questions from lattice vibrations and free electron theory. Okay, so almost all CSIR questions given, and gate questions you please solve. Don't neglect, don't neglect. Just wait, relax. Right. Ready? Now take the fresh page and put the heading degenerate Fermi gas. Strongly degenerate we have taken. Now we are discussing the last one, Amma. With this complete lattice vibrations, free electron theory, everything is complete. And the next we will start the band theory of solids. Right. Degenerate free electron gas or fermion gas or free electron gas. Amma? Degenerate free electron gas at a temperature T greater than 0 Kelvin. In the last class we have discussed at T equal to 0 Kelvin and we got the Fermi energy and everything. And I told you one statement, I don't know how many of you remember. At T equal to 0 Kelvin, our Fermi energy is independent of temperature. But here we are considering the not weakly degenerate, not strongly degenerate, moderate, degenerate. Okay, right. So the degenerate Fermi electron gas at T is greater than 0 Kelvin. Everybody, very important. So what we have taken, first distribution function, f of E equal to 1 over e raised to beta E minus EF plus 1. Strictly speaking, you have to write mu. I am taking that mu is nearly equal to EF. The reason is I have taken degenerate, okay, not strongly degenerate. Good. So this can be written as I have taken nearly mu equal to F 1 by e raised to E minus EF by KBT, because the T is not equal to 0, no problem, plus 1. Okay. So I hope if you remember, we have already discussed this one more time. And this is the energy E. And here we have somewhere Fermi energy. Listen carefully. So this is the distribution function. And we got a curve. This is the constant which is equal to 1. That means below the Fermi level all states are filled and above the Fermi level all states are empty, where at T equal to 0 Kelvin. This is at T equal to 0 Kelvin. And after that what I explained, if the temperature is increased, what will happen? Those electrons which are below the Fermi level gain thermal energy and they will excite to the higher states which are vacant at T equal to 0 Kelvin. At T equal to 0 Kelvin, here vacant states are there. Good. 1 minute. So at T is, as a T increase, so what will happen? Some of the electrons here, they will excite to the higher states. Say yes or no? And here we are getting a vacant and here we are getting a electron. Now let us suppose this is the earlier we have one electron at a location X or something like that. Then could you please tell me what is its energy? E equal to EF below, that's why minus X. Say yes or no? Now this electron is jumping to the higher states. Could you please tell me what is its location? Let us say again X here, E equal to EF plus X. Okay, so once it is going to the excited states, here we are getting unoccupied states. Here you are getting occupied states. Okay. Now here we are getting some, okay, fine. So let me find, very important, let me find fraction of occupied states. Fraction of occupied states. Are you ready? So I am going to take the fraction of occupied states. I can take f of E, that is 1 by e raised to E minus EF by KBT. Just wait. KBT plus 1. What is this? Fraction of occupied. Okay na? So this is occupied and this is what? Unoccupied. Carefully observe please. Fine. Whenever you are talking about occupied, could you please tell me what is the energy? E equal to? Good. E equal to EF plus X. Plus. Shall I bring this EF this side? Come on. E minus EF equal to, now substitute, F of E equal to 1 by E raised to X plus 1. Okay. E raised to X by KBT plus 1. What is this ma? This is the fraction of occupied or unoccupied? Occupied. Ready? Okay, cool. Now, once again, are you listening? This is the fraction of occupied. 1 minute. Here I would like to find a fraction of unoccupied. Here one important question is there. That's why I am explaining this. Listen carefully. Fraction of unoccupied. Fraction of occupied plus fraction of unoccupied should be equal to 1 unit. Say yes or no? So fraction of occupied is this one, means fraction of unoccupied is 1 minus of this. So fraction of unoccupied, F of E, unoccupied is nothing but 1 minus F of E occupied. This is occupied na? Wait a minute. 1 minus 1 by E raised to E minus EF, slowly, by KBT plus 1. If you take the LCM, this will go to the numerator, plus 1, minus 1 gets cancelled. This will be in the numerator. This is in the denominator. Again bring it down. Then 1 by 1 plus E raised to minus of, very few people are saying. Are you understanding? This is the fraction. This is the fraction of unoccupied or occupied. Again, go back to the unoccupied condition. What is the energy for unoccupied? Could you please bring this side? E minus EF equal to, now please take it and substitute. You will get a surprising answer. Fraction of unoccupied equal to 1 by 1 plus what is that? Say. So they will ask this question in interviews. Generally, definitely they will ask framing a question on a Fermi energy, no doubt about it. So for example, they are asking like this. What do you know about a Fermi energy distribution at T equal to 0 Kelvin? What you will say? Sir, below the Fermi level, all states are occupied. Above the Fermi level, all states are empty. If they will ask, please draw, then you will draw this. Then they will ask this one. As the temperature increases, what will happen to that curve? What is your answer? Equally means what? Some word is there. Symmetric. Fraction of unoccupied equal to fraction of unoccupied. Then this curve, whatever you are taking, the distribution curve, that will be symmetric about Fermi level. That is the point you have to say. So finally here the conclusion is, once again, fraction of unoccupied below Fermi level is equal to fraction of occupied states, okay, above Fermi level. So that's why you have to say the answer. The distribution is symmetric, symmetric. This means symmetric about Fermi level. That's it. Okay, come on, right. Here we can't derive like yesterday at t equal to 0 Kelvin everything. The reason is Riemann zeta integrals will come. So we have to write directly. So no need to get tension. But you have to remember, this is your set question. Which of the following is the Fermi energy level at a t not equal to 0 Kelvin? The fraction of unoccupied states below the Fermi level is equal to the fraction of occupied states above the Fermi level, as a T is not equal to 0 Kelvin or greater than 0 Kelvin. T equal to 0 Kelvin is possible? Is it possible? If possible, what will happen? Zero volume. Ready? Not over. Ready? Yeah? Is it completed? Still anyone is writing? Calculate. Ready? Stop. Now at T is not equal to 0 Kelvin, we have to find the Fermi energy. If you want to find the Fermi energy, you have to find a capital N first. Listen please. A small derivation, but we can't do it completely. Just wait a minute. N equal to, I think if you remember in the last class, this is a 0 to infinity, N of E dE. Say yes or no? N of E is nothing but F of E, G of E. That's good. So that's why N equal to, I hope everybody know what is the distribution function and what is the density of states. 1 minute. Ready? So I am writing this density of states V by 2 pi square H cross square by V by 2 pi square na H cross square by 2m whole power 3 by. First write the constants outside. Now integral. Now this distribution function you know 1 by e raised to e minus ef by kbt minus a 1 plus 1 minus 1 కాదు plus 1 into in the density of states you have something e power 1 by 2 into check anything is miss 2m by h cross square oh this is a Fermi energy okay come on 2m by h cross square whole power 3 by. Say yes or no? Wait. Just I have substituted f of e here and g of e. Write the constants outside and remaining this integral got. This integral is called Riemann zeta integral. You know? How much? How do you know? Hey, you remember? Riemann zeta. Listen. After substituting this entire integral, I will write the final value, all of you. Let me take the final value, Babu. So V by 2 pi square 2m by h cross square whole power 3 by 2. This is a 2 by 3 ef power 3 by 2. Once again 2 by 3 ef power 3 by 2 into 1 plus pi square by 8 into kbt by f of 0. So much derivations will be there, but leave it all the things and finally get back to this. You need not to remember this also, no need. So this is the number of electrons when T is not equal to 0 Kelvin. Wait a minute. Here we have to take an approximation. What we are assuming is, listen, although T is greater than 0, that means although T is greater than 0, we are assuming still the gas is degenerate. Still the system is degenerate. Still the system is degenerate. That's why you can assume like this. What is that approximation? N at T not equal to 0 is nearly equal to N at T equal to 0. The similar kind of approximation we will take in a Bose-Einstein condensation also. Okay, there also will take the same thing. We will find the number of bosons. Here we are finding the number of fermions. Only the change is what? Distribution function. Here what you will get? Minus. Okay, and here that temperature is called Bose temperature. Here we call it as a Fermi temperature. Okay. So once again, although temperature is not equal to 0 Kelvin, just we are assuming still the system is degenerate. That's why you can take this approximation. Then V by 2 pi square 2m by h cross square. This result is very crucial. Observe 2 by 3 ef power 3 by 2. This is the Fermi energy of what? At temperature. That's why at temperature is not equal to 0 Kelvin. That's why I am representing as a of T. Okay. Into 1 plus pi square by 8 kBT by EF of 0 whole square. Slowly. I hope everybody know what is the number of electrons at T equal to 0. Everybody know, I think. Come on. V by number. V by 3 pi square 2m by h cross square whole power 3 by 2 EF power. You remember? Actually EF power 1 by 2. Once you integrate you got EF power 3 by 2 into 2 by 3. 2 gets cancelled 3. Okay, V by 2 pi square, V by 2 pi square, this 2, this 3 gets cancelled. One more time I am saying, similar kind of mathematics we will do in the Bose-Einstein condensation. So please remember that. Okay, then what's the remaining? Could you please tell me? This is EF of 0. Is it okay? Now come on, say EF of T whole power equal to, into shall I? Okay, then finally again the final expression, everybody must remember this, EF of T equal to EF at 0 Kelvin into, ready, 1 minus pi square by 8 kBT by EF of 0 whole square whole power. Okay, so finally this is the Fermi energy formula at T is not equal to 0 Kelvin. You must remember this. EF of T equal to EF of 0 into 1 minus pi square by 8 kBT by EF of 0 whole square whole power 2 by 3. Yeah, it's possible to remember. EF of T equal to EF of 0 1 minus pi square by 8. Oh, they have taken 1 minute. 1 minute. They have taken final binomial expansion. No problem, don't get tension. Minus 2 by. Now finally, again binomial approximation. Minus 2 by 3. Come on. This is not the final. EF of T equal to EF of 0. 1 minus 2 by 3. 12. Pi square by 12 kBT by EF of 0 whole square. This is the final formula. Because already we have taken some approximation like that. I mean this value is very less value because you are taking not a very high temperature, okay, low temperature only for taking. So that's why you can apply the binomial expansion. So finally EF of T equal to EF of 0 1 minus pi square by 12 kBT EF of 0 whole square. Similarly, I am writing that average energy, okay, just writing, please come on, start. Average energy at a temperature T. I will write the final expression for that also. Just remember in case But if you are writing a set exam, don't forget these two expressions. Either you will get a Fermi energy or average energy. Average energy at T equal to average energy at 0 into 1 plus not minus plus 5 pi square by 12 kBT by EF of 0. And again if you find this CV equal to nothing but dou U by dou T, and again you will get a proportional to T. Although T is not equal to 0, again the contribution of the free electrons is a CV is a proportional to T only. Yeah, it's a T square na. T square, differentiation is what? T. So the free electron contribution to the specific heat is proportional to T at a T equal to 0 Kelvin as well as T is not equal to 0 Kelvin or T greater than 0 Kelvin. If x is a small, 1 plus x whole power n is nearly equal to 1 plus nx. Just that one, that's why they multiply with minus 2 by 3. Please remember, it's not possible to derive also, please remember. EF of t equal to EF of 0 into 1 minus pi square by 12, minus pi square by 12 kBT by EF of 0. Or sometimes they will write kb square outside. After that EF of 0 they will write it as kb TF of 0, then kb cancel into kb T by TF whole square. Over.